Ladies and gentlemen, we'd like to inform you of our Bureau de Change facility on board, offering commission.
Neil Gretton is a university student, supplementing his income with work on the P&O cross-channel ferry that runs between Dover in England and Calais in France.
I was going to go to university. I planned to go to uni and decided to take a year out. And I lived in Dover at the time, so it was quite it is quite a well-paid job for Dover. So I applied, got the job, and spent my gap year working here. And then I applied to go part-time when I started university, and they've allowed me to do 2 days a week while I've been studying at university, and then come back in the summers full-time in order to kind of pay my way, really. I'm planning to train as a teacher next year and study for a teaching qualification.
A ship this size requires many crew members to pilot, load and unload, and serve customers during the journey. How are wages determined for these different types of labour? In particular, how much does Neil get paid? His wage is determined by the supply and demand for labour services. The price of labour services is the wage rate. So let's use linear equations for the supply and demand for labour to determine the equilibrium wage rate. There are different markets for different types of labour, whether it's the unskilled day labourers in the USA, or the workers on the ferries, or indeed office work. The market for any type of labour is represented by LD, the number of workers firms wish to hire depending on the price of labour services, that is to say the wage rate per period of time, expressed in whatever is the local currency. But we've also got a supply curve for labour, LS, showing the number of workers willing to work, which is going to depend upon the wage rates that they're offered. So if we know the demand and the supply curve for labour, then we can calculate the equilibrium wage rate for any particular kind of labour. Now the demand curve for labour will take this kind of form. LD equals 5,000 minus 12W, where LD is the demand for labour and W is the wage rate, say in pounds per week. The supply of a particular kind of labour could be shown as something like LS equals 2,000 plus 3W. Notice that for LD we've got a minus sign for W, and for LS we've got a plus sign, the minus sign showing that as the wage rate falls, firms wish to hire more labour. The plus sign in the labour supply curve shows that as the wage rate rises, more people are willing to offer their services for work in the industry. Now equilibrium is found by solving these simultaneous equations. In equilibrium, 2,000 plus 3W equals 5,000 minus 12W, so 15W equals 3,000, W equals 200. So for say a 40-hour week, the hourly wage rate for this kind of labour is 200 over 40, gives us £5 per hour as the equilibrium wage rate. We can also use our equations to find the number of people employed in the industry at that equilibrium wage rate. And we can do that simply by substituting W equals 200 into either of our equations. For example, using the labour supply curve, LS equals 2,000 plus 3W, but we've already calculated W, so LS equals 2,000 plus 3 times 200, so LS equals 2,600 workers. So a person can get a job in this particular market if they're willing to accept the going wage rate W. And labour can be hired in this kind of market if the buyer of labour is prepared to offer that going wage rate. Our linear equations enable us to discover the wage rate and indeed the size of employment in an industry.